stiffness, and suspension component loads. A car suspension is the system of tire air, springs, shock absorbers, and linkages that connects the vehicle to its wheels and allows relative motion between the two. Suspension systems serve dual purposes, contributing to the vehicle roll handling and braking for good active safety and driving pleasure, and keeping the vehicle occupants comfortable and ride quality reasonable, well isolated from road noises, bumps, vibration, etc. Stiffness is a very important concept for a suspension. It is based on a Hooke's law that represents the resistance of a springs to move.
Spring rate. Spring rate refers to the amount of weight that is needed to compress a spring 1 inch. For example, if you have 200 pounds per inch spring on the top of the spring, this will compress 1 inch. If you have another 200 pounds, it will compress 2 inches. Suspension rate. Suspension rate is the trouble that the suspension have during the change of loads in the car when it moves. For example, the suspension can go up or down depending the load that is acting in this part of the car. For example, another part of the suspension rate is the geometry, that is SLA, short long arm. The advantage of this suspension geometry is that it can influence in the configuration of the camber angle. For example, when you take a cornering, it can change like in negative or positive camber.
Wheel rate is basically the spring rotate to measure at the wheel, a spring attached to the linkage. It is basically spring rate multiplied by the motion radio square, and the motion radio is between how much the spring for this part is compressed to compare to how much the wheel is actually moved on this part for the wheel.
Tire rate. The tire rate is the amount of force that the tire can absorb from the outside. If you know, the tire is soft and also can absorb part of the vibrations and bumpers that you usually found on the streets. It's defined as the vertical force per unit vertical displacement, and this distance depends on the coefficient of the spring and coefficient of the tire.
For an SLA suspension, the forces act as shown in the figure. To find the resulting vector, we use the graphical method of forces. For this method, the vectors are added together to form a polygon, like this. We start to put the FL force, then we add the FN force, then add the weight force, then the FULA force, and the last one, the FLCA force. The tip of the resulting vector starting from the origin, like this. And this is the resulting vector of this figure.